Okay, so let's look at the solution for the selection sort. So the selection sort takes in an array, or it's going to function that we're going to take in an array, and we're going to sort that function. So if we initially start off with an array, like let's do this one right here, then what we want to do is we want to create a function that accepts an array, any array of any length, and it's going to sort it. So in the end, what we should be returned is a sorted array like this, right? So here we start off with this array and we're going to end up with this. So as a quick overview, let's look at kind of an algorithm that we can use to help us build up our function. So we're first going to store the first element as the smallest value that we've seen so far. And then we're going to compare this item to the next item in the array until we find a smaller number. And if a smaller number is found, then we're going to designate that smaller number to be the minimum and continue until the end of the array. And if the minimum is not the value or the index that we initially began with, then we're going to swap the values. And we're going to repeat this process until the end when the array is sorted. So let's start off with, let's just create a function, and we're going to call this function just selection sort. And this function is going to take as a parameter an array. And in the end, I'm going to go ahead and put this here. We're going to return a sorted array. So this is going to be our sorted array. And I always like to go ahead and put what we're going to return, because sometimes people, especially in interview settings, you'll forget to return something. And so you want to make sure that you're returning something. So when we make this function call, like when we call selection sort, we should be able to pass in an array. So we'll pass in this array right here. And our result should be a so let result equal to selection sort. Our result should be a sorted array. So if we console log out our result, then what we should get is a sorted array. Currently, all we're going to get is just the array itself right now. Okay, so let's start building up our logic. Okay, so the very first thing that we're going to do is we're going to create a loop. So this sorted array, or this selection sort, is considered a naive sort. So it's going to be quadratic in time. And there are other sorts that are a lot faster, not a lot faster, but they're faster, but they're going to be more complicated to understand. So there's a certain group of sorting algorithms that are called naive sorts, and this is one of them. All right, so let's start off. We're going to create a for loop. So we're going to create a, quadratic in time means we're going to have nested loops. So we're going to create this outside loop, and this outside loop is going to be responsible for moving along. So let's just create it first and then we'll explain it. So we're going to create a for loop with an index I, and we're going to let that index start off at 0. And then we're going to, the end of that, we're going to go up to where the length of our array. So, and then we're going to increment our index, our I. So this right here, like if we're looping along, then let's say that this is going to be our I right here. So I'm just going to put a little I right here, like a little stopper right here. This is going to be our I. So we start off at I equals 0. So that's going to be that 34 right there. So the next thing that we want to do is we want to create a variable called smallest. So let smallest equal to 0 or equal to I. So initially our smallest is also equal to I. So we're going to assume the smallest value in this array right now is sitting at the value of 34. It's sitting at the index of where 34 is, right? So smallest is an index value, and currently it's equal to 0. So now we're going to create another, like an inner loop, right? It's like a nested loop. So let's create let j, and we don't want, this j is going to be used, or this inner loop is going to be used to loop through all of the remaining elements of our array. So we're going to loop through 22, 10, 19, and 17. And what we're doing is we're comparing those numbers to the value with the smallest index. So currently, our smallest index is sitting at 34, and we don't want to compare it to ourselves. So we're going to let j start not at 0, because that would mean that it would start off at the same, we would compare at some point 34 to 34, and we don't want to do that. So we're going to let j equal to I plus 1. So whatever I is, and currently, at the beginning, I is 0. So whatever I is, it's going to be one element after that. So j is going to start here, right? So j, if you look up here, j is going to start at 22. All right, so to continue our loop, we're going to let j go all the way to the array dot length, and then we're going to increment our j. All right, so initially, so what we're going to do is we're going to compare. We're going to say if the array at element j, so what is the array at element j? Well, that is going to be a value of 22 initially, like when we first start the loop, right? So we're going to look to see, we're building a condition here, if that value is less than the array at the smallest index, right? And our smallest, we said right here at the very top here that we have set s, right, the smallest index, to 0 right now. It's initially starting off at 0 because I is 0. Okay, so if this is true, and what we're asking is an array j, which is a value of 22, is that less than the array at smallest, right? So 22 is less than 34. So then what we're going to do is we're going to reset smallest. So now smallest is going to equal to j. So j is, the value of j at this point is 1 more than I, which is 1. So now smallest has now a new value of 1, right? So let's make another little section here, and these are just going to number our array elements. So this is 0, and then this is 1, this is 2, this is 3, and this is 4, all right? So here, as we're looping through, we're currently on our j is equal to 1, right? So now we're saying, yes, smallest is going to be reset to j, which now it's 1, and then we're going to go back through and we're going to have to keep on executing each part of our inner loop until we finish, right? So now j is going to increment to the next value, which now j is equal to 2, right? So then we're going to ask ourselves, is the array at element j, so element j is at this 10, the value is 10, is that less than the array at smallest? Well, the array at smallest, because s is 1, is 22. So what we're asking is 10 less than 22, and it is. So we're going to reset s, the smallest value again. We're going to reset that to j, which is going to be now s, the smallest is 2. So then we're going to go back, because we haven't finished our inner loop yet, and we're going to get to an element or a value where j is equal to 3. So when j is equal to 3, we're going to ask ourselves, is the array at element j, which is 19, is that less than the array at smallest? And it's not. So then we are going to keep s where it is, because that's the smallest right now. So then we go to the next element in that inner loop, which is 17. So j is 4 now, and we're going to ask ourselves, is the array at j, which is 17, is that less than the array at smallest? So the array at smallest is the value of 10, because the smallest index is set to 2 at this point. So it isn't, so then s remains the same. So now we're done with that inner loop, and we jump out of this code block right here. And before we go on and reset I, what we're going to do is we're going to swap. So we're going to say if I is not equal to smallest, which I at this point is, remember we started off, I is 0 at this point. So I is still 0. So we're asking ourselves, if I is not equal to smallest, and it's not, because smallest is 2. So if I is not equal to smallest, then what we're going to do is we're going to swap, right? There's no point in swapping if I were equal to smallest. So that would mean that our smallest value was already at the beginning of the array. So if we change that 34 to 0, then in our past all the way through here, 0 was actually smaller than all these other values. So the smallest, this smallest variable right here would never change. So here, if the I is not equal to smallest, then what we're going to do is we're going to swap. So in ES6, there's a way to swap variables in an array. And because typically when you swap values, you have to create a temporary variable and then do the swap. So in ES6, the way that we can swap things is we can say array at I, right? And the array at smallest. We want to swap those with, and here on the other side of the equals, we're going to swap the value. So array at I, we want to swap that with array at smallest. And then we're going to swap the array at smallest with the array at I. So now what happens is in our array here, the value where S, the index is at 2, where that smallest index is, and the value at I are going to swap. So now 10 is going to become 34, and 34 is going to become 10. And so now the smallest value in that array has now been pushed up to the beginning and it's sorted. So now now we're done with this whole inner loop, right? This whole block has executed and this has executed. So we go back up to our condition and we increment our I. I is still less than the array dot length. So we're going to increment our I. And so now I is going to be set to 2, right? So we're going to move I up to here to 1. Sorry, I is now 1. So I is now 1 and J is going to be, so we have to reset things. J is going to be I plus 1. So that means that J is now going to be 2. And S, we're going to set to be, we're going to assume that the smallest index is actually going to be where I is. So we start off assuming that S, the smallest index, is going to be index 1. So it's going to be that's value of 22. And the reason why we do this is we don't want to look at this anymore. We don't want to look at the 10 anymore. It's already sorted. So we're just looking at the remaining elements of 22, 34, 19, and 17. So now we start our loop all over again, right? So now J is equal to 2. It's 1 more than what I is. And we're going to ask ourselves, is the array at J, which is a value of 34, is that smaller than the array at smallest, right? So the array at smallest is going to be the value at 22. And 34 is not less than 22, so S, the smallest index, is going to remain the same. So then we're going to increment J. And so now we're at J of 3. Like it's now J is, the value of J is 3. So then we're going to ask ourselves again, is the array of J, which is the value of 19, is it smaller than the array at smallest, which is the value at 22? And it is. So we're going to reset smallest to J. So that moves our S value up to 3, right? So then we go back. We haven't completed yet. So we're going to go back and we're going to increment J. So now J has a value of 4. And we ask ourselves, is the array at J, which is a value of 17, is that less than the array of smallest, which is a value of 19, right? And it is. The array at J is smaller. So we're going to reset that smallest value to J. So now S becomes 4. So then we are done with this inner loop and we're going to look at swapping. So we're going to ask ourselves, is I, if I is not equal to smallest, which I right now is equal to 1, and smallest is equal to 4. So if I is not equal to smallest, which is the case in our case, then we're going to swap. We're going to swap the value of where we found smallest and that index of where we started. So now 22 is going to become 17 and 17 is going to become 22. And now we have 2 items that are sorted. So then we have to reset everything, right? So now we're done with this whole block here and we go back to our condition where we increment I. So I now becomes a value of 2, right? J is 1 more than I, so it's at 19. And S is, we're going to assume that S, the biggest value, the smallest value right now is going to be S at I. So then we go through the whole process again. We ask ourselves, is J, or the array at J, which is the value of 19, is it smaller than the array at smallest? The array at smallest is 34. So that's not the case, so we increment j. So now j is 4, it has a value of 4. So we're going to ask ourselves, is the array at j, which is the 22, is that less than the array at smallest, which is 34? And that's true. So we're going to change, we're going to use this line right here, we're going to change s to the value of j. So now we've reached the end, and we're going to ask ourselves this question right here, is I, not, if I is not equal to smallest, so I is 2 at this point, and s, or the smallest index, is 4, and they're not equal, so we're going to swap. So 22 and 34 are going to be swapped. So 34 becomes here, and 22 becomes here. You know, I did something wrong. We should have stayed at 19. So 19 was the smallest. I'll put s here. So 19 was actually the smallest here in this pass. I got ahead of myself. So here we're going to swap 19 and 34. So 19 becomes here, and 34 becomes here. So then we have to restart our variables. We're going to increment our I. So I now becomes 3. J is 1 more than I, right? And S is, we're going to assume that it starts off at what I is. So then we ask ourselves, is the array at J, which is the value of 22, is that less than the array at smallest, which is 34? And it is. So we're going to switch S to 4. And then we're going to do our swap. So now we're going to swap, and we're going to put 22 here and 34 here. And then we have a sorted array. So if we run this code now, let's see. Where am I? So if we run, let's see, I got a little error here. Oh, so there's one thing that you should know about this right here. You always need to have a semicolon. There's a couple situations where you actually need to have a semicolon, and this is one of them. And so for this, you're going to have a semicolon. Let's see. Undefined is not a function. Here, I have too many brackets in here. It should just be the arrays inside of here. So I had one too many brackets in here, got carried away. So we're just going to clean this up. It just should be just one, what you're looking at, it should just be this is equal to this. And then inside of there, you have the elements that you want to swap. All right, so now if we run our code, then we get our sorted array. So 10, 17, 19, 22, and 34. So our array is sorted. And that is it. So let's look at the time complexity one more time. The time complexity of a selection sort is going to be quadratic. And the space complexity, which is kind of like time complexity, but how much memory you're using is also just going to be, it's going to be constant, because we're only setting what we're creating one variable, and that's the only variable that we're using, and it just, the value changes, but we're not creating the storage, like the memory doesn't grow as our loop continues on and on. It's just one variable that we're setting, so it's constant time, it's constant space. Okay, so that's it.